We have been studying these parabolas, and we know of 4 different parts of the parabola that we know how to find. So at the top here, we have the vertex. That's going to be our highest point since our parabola is facing downward. And at that vertex, we can find either the minimum or the maximum. And in this case, it's typically a maximum. And when you find that minimum or maximum, that's going to be the y-coordinate for the vertex. I also have this vertical dashed line representing the axis of symmetry, and that's going to be the x-coordinate of the vertex that you would plug in to find that y-coordinate. So that's when we use the formula x equals the opposite of b over 2a. And that's going to be whatever the input is for the equation in the given problem. We also know what this point is here over on the left. This is what we would have as our y-intercept. It's where our graph crosses the y-axis. The x-coordinate is 0, and the value will come from the c in the equation. Lastly, I have these 2 points on the bottom on the x-axis. Those would be our x-intercepts that we also consider to be our zeros. So to find those zeros, we were going to have to factor. Finding the zeros will help us determine how long something was in the air. So this would be time of flight or time to touch the ground. So when we do these word problems, we have 3 particular questions that we're asked. So the first one could be time to maximum height. So since it's the time to our maximum height, this is going to be our input. So this is going to be the x-coordinate of our vertex. And we find that using the formula of the negative b over 2a. The second question can come from our maximum height. So this is going to be the vertex itself, and it is our y-coordinate. And once we found the x, we're just going to plug that in to find the y. Then the last question is length of flight, or time in air. So this would be your zeros, so we are going to have to factor to find those 2 answers. So when we go through the word problems, you want to think about these 3 different questions that they could be asking you, so then you know what math you need to do in order to solve the problem. So let's look at an example. So here in our problem, we have that Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function f of t equals negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. So in part A, I want to know how long will it take Jason to reach his maximum height. So if I go back to my 3-question table, I want to figure out, is that question 1, 2, or 3? Since it says how long it will take to reach his maximum height, that's question 1. So that's going to be the x-coordinate of our vertex. That's going to be our input value. So we use the formula x equals the opposite of b over 2a. So in my problem, my a is negative 16, my b is positive 16, and my c is 480. So I'm going to plug in negative 16 divided by 2 times a negative 16. That gives me the fraction of negative 16 over negative 32, which simplifies to 1/2. And we can change that 1/2 into a decimal, and that would be 0.5. And since we were talking about time, it's going to be half a second for when Jason is going to reach his maximum height. Now in part B, we want to know what Jason's maximum height is. So if I go back to my table, I look and I see that this is question 2 of my 3 questions that I could be asked, and I'm going to take that x-coordinate we found and plug it into the equation. So I'm going to have y equals negative 16 times 0.5 squared plus 16 times 0.5 plus 480. I'm going to type that into my calculator to find his maximum height. I get 484, and since we're talking about height, that is feet. Okay, so Jason jumped up to a height of 484 feet, so that sounds like a lot, but if we go back up into our problem, But if we go back up and into our problem and I look at my C, remember that's your y-intercept. So that y-intercept is going to represent his starting height. And Jason started at 480 feet in the air. So he really only jumped 4 feet before he started falling. Now in C, how long will it take Jason to reach the ocean? So if I go back, this is going to be my last question. So how long will it take him to reach the ground? So I need to factor, I need to find my zeros. I'm going to take my equation and I'm going to set it equal to 0. And since it has an A term, a B term, and a C term, I'm going to try and factor it using the British or the box method. So if I look at negative 16, 16, and 408, they all can be divided by a negative 16. And I'm going to use a negative 16 because I want that A term to be positive. So my new equation is going to be t squared minus 1t minus 30. Now I'm going to see if I can factor. So you can either use the British or you can use the box method. Now that I've factored, I have t minus 6 and t plus 5. I'm going to set both of those equal to 0, and I'm going to solve. I get two answers, t equal to 6 and t equal to negative 5. So I want the answer that's going to make the most sense, and since we're talking about how long it's going to take Jason, the negative 5 isn't going to make any sense for my problem. So the 6 is the only answer that will work. So it's going to take him 6 seconds from the time he jumps off that cliff to land in the water.